Good evening, Professor. My name is Mui Hiang, and today I will be presenting Project 4 of our CSCI 331 operating system course. So for this project, we are just comparing performance of page replacement algorithm, which is first in, first out, and least recently used. So let's get into our code. So first we have our helper function. So basically this helper function is just to search like for a page within the frame array. So if there is the page, then we can just so if there is like a page, then we can just return the index. If not, we can just return -1 not found. So let's get into our reference, creating a reference string. So our reference string is just basically like we generate page that the operating system need or the CPU use for operating something. So here we're just saving the result of our generated page and then as well as the length we want to reserve for those pages. So here we're just basically generating a like seed generator, and then we can get our random number generator. And here we are just getting the transition probability, so ranging from 0 to 1. And this is our locus offsets. And the last one, we're just generating the page selectors. So which page is being selected. So first we start with page 0. And here we're just, we're just generating a rate motion of reference within the current locus. So here we just, first we're getting the random offset where we want to start. And then like offset, for instance, how many offset we want starting from 0. And then our basically ensuring that page wrap around. So like depending on the start and offset, making sure that it doesn't go beyond the boundary of our range that we have set. And then we can just push the page. So basically adding the page to our reference. So we're still generating our reference string. So here we're just checking if the locus is lesser than our prop. So if it is, then we generate a new starts. So it doesn't overlay. So if it's not then we can just shift it a little bit to the right by 1. And then we can just return our result that we have generated. So first, let's get into our first algorithm, which is first in, first out. So our algorithm, first we basically have to have like an empty space for our frames. So we initialize all of it to -1. This will be to keep track of our oldest, and then our page fault to keep track of how many page fault has been generated within this algorithm. So here we're just iterating through our reference string. And we're using our helper function to check whether there is a page fault or not. So if there is a page fault, then we have to replace the oldest page within our frame with the newest one. So this is just to move on to the next frame. So and then we have to make sure we increase our page fault to keep track of how many page fault we have generated. Then we returns the page fault. So here is our second algorithm, least recently used algorithm. So of course we need space for our frames, and then we have to initialize our page fault to keep track. Here we are iterating through the reference string again. So now we're just searching. So we're searching whether the page is in the frame. So if it's if it didn't find the page that it's looking for, so that means there's a page fault. So there's a new page that we need to insert. So we increase our page fault first to keep track, and then this one is just rechecking if like the frame are really full. So if the frame is full, then we have to remove the least recently used, which is the beginning. So it's in a way it's similar to the first in, first out, except that so first after we remove the recently used page within the frame, then we can push our new page within that frame. And then we have to, so this is the second condition that makes it different from first in, first out. So if it's out, so that means there's no page false. So that means like the page already exists in the frame. So then we can just remove that page and put it back so that it's like the recently used, so it's not in front anymore because it has been referenced again. So here's just my test function just to test with the given reference string and then the number of frames. So this is just the result from how many page fault is generated within both algorithms. And this is also my other test function, basically inputting all the size, the reference string length, the motion, all the frames, number of frames. So let's run our code. So first, we will see our first test function, which is here. That we is right here, our run verification test. So we can see that first in, first out generated around 10 page fault, while least recently used page only generates 7. So I won't be running the interactive single test because it's just basically this test function, except that you have to enter manually for each variable. So I will skip that for now. So we will run our second test. So here we can see a comparison graph like between like specific locus and probability. So we can see there's in our difference in terms of locus, there isn't much of a difference, like a really small difference, whether the locus is increasing or decreasing, or in terms like small or larger, it doesn't make that much of a difference. But for our probability, we can see that as the probability increase, there's like a really big gap between these two functions. We can see that least recently used is way lesser than first in, first out. So this is the comparison between the performance, and this will be the end of my presentation. Thank you so much for listening.